This video tutorial is not intended to teach you about all the details of how to do a zone pressure diagnostics test in the field. You'll have to look elsewhere for that. The primary objective of this video tutorial is to give you good instruction on how to use the Residential Energy Dynamics Zone Pressure Diagnostics tool. We're looking now at an overall view of the RED tool, the ZPD tool. There are three major sections to this tool. You can see them as you look at it. First of all, initial zone configuration. This is where you put the data for the test before you open a hole or a door. The next primary section is modified zone configuration. After you do open a hole or a door, this is where you put the resulting pressures with that hole or door open and the resulting whole house CFM50. And then finally, and most importantly, the results for initial zone configuration. Here you have the CFM50 values for zone to house pressure boundary, zone to outdoor pressure boundary, and the through zone pressure boundary. Soon I will go through more detail on each of the sections of the tool. All right, let's do an example with ZPD to an attic. We'll treat the attic as a zone. Here we have the setup. We're going to use one digital manometer because most of you will only have one. We set up the blower door, and in this case we're going to depressurize the house to 50 pascals. You could also pressurize. We take a hose and we put it up in the attic hatch, and then we close the attic hatch again. Make sure that you don't totally block the hose or crimp the hose when you do this. It's a good idea if the hose is at least 3 feet away from the attic hatch to keep it out of any airflow. Of course, this drawing does not represent that very well, but that's a problem with my drawing. So we have on the right side of the digital gauge, we are measuring the house with reference to the attic. Then on the other side of the gauge, the left side, we're measuring the house with reference to outdoors. And this just makes, we're checking, we're verifying that we do have 50 pascals of pressure. And when we do the blower door test in the initial configuration, which is this one, we found that the whole house CFM50 is 2400 with the hole closed. Now I'll show you how I enter these numbers in the RED tool. Here's the top of the RED tool, not the whole thing, but most of it is here. I'll scroll down. Attic at the Jones house is what I'm calling this. The blower door test type is depressurization. We could choose pressurization. I am not now going to use the advanced inputs. I could if I wanted to, of course. And let's assume that we are using the baseline feature of the digital gauge. So the blower door off pressure, or the baseline pressure, is 0. Blower door on is 50 pascals, and here we must enter the negative sign because we are depressurizing. If we were pressurizing, we would not have to enter a sign. And here we then have the delta pressure. It does the subtraction for you, and negative 50. Now, with our house to the zone pressure, we found that that's a negative 32, and that is measured right here, a negative 32, and input here. Again, we're assuming we're using the auto baseline feature of the digital gauge, and we put 0 there, and negative 32 here. Again, the sign is important, and we are inputting the house with reference to the zone rather than the zone with reference to the outdoors. And then finally, we need the whole house CFM 50. That value is right here, the whole house CFM 50, and that is entered right here in this input box. And as I've said already, you are able to change the units if you wish to do so. The zone leakage ratio, the zone to the house, with reference to the zone to the outdoors, is 1 to 1.5. Now that we've looked at the initial zone configuration, we're going to look at the modified zone configuration. In other words, how are we going to change things so that we get different pressures and a different whole house CFM 50? We compare that with the initial case, and it gives us the results we need with the use of our calculation tool. We are still measuring from the house with reference to the zone. We have a blue hose up in the attic. In this case, for the modified zone configuration, we remove the attic hatch totally, so we have a lot of air flowing down through. When doing that, be careful that you don't bring cellulose or other debris down from the attic. We still have a hose to the outdoors that checks to see if we are at 50 pascals. Of course, once you open this hole or open a door, you're going to have to increase the revolutions of the blower door to keep the house at 50. Now let's take a look at how this is entered in the RED tool. Here is the modified zone configuration in the RED tool. Here's the initial, by the way. Both can be seen at one time. We are opening a hole or a door located between the zone and the house. We have the choice of the zone and the outdoors. Remember, we want to open this hole in the pressure boundary that is the most resistant to airflow. In other words, the pressure boundary with the highest pressure difference in pascals. The type of modification you're almost always going to use, add a hole or open a door, but you can close one. So based on our example, again, if we use the baseline, this is 0. The blower door is depressurizing to 50 pascals. Here is the pressure difference. House with reference to zone. There is a choice here. And we now have 15. We started at 32. We shifted the pressure down to 15 by opening the hole. That's a pressure shift of 17. That's pretty good. And we end up then with a whole house CFM 50 of 2950. That's an increase from 2400. So going back to the example, you see this is what we've got. And just to show you, I'm going to go back to the initial zone configuration. This is where we started. This is the modified zone configuration. And with the entries in the tool, this is what we have. The initial zone configuration, those numbers are entered here. The modified zone configuration, those numbers are entered here. And if I scroll down, you see the results. What we have for the house to zone leakage in units of CFM 50 is 1400 plus or minus 600. And in leakage area, that's approximately 140 square inches plus or minus 64. This is the uncertainty as a percentage. From the zone to the outdoors, we have 2000 CFM 50 as a flow plus or minus 650, and this is the square inches of leakage plus or minus 72, and the uncertainty and the through zone, sometimes referred to as the total path, is 1000 plus or minus 410 with a 40% uncertainty. So these are very powerful results. We can do a lot with these. Just a few words about uncertainty over here, and the uncertainty absolute numbers listed after these values. Zone pressure diagnostics has always had uncertainty attached to it, but what we chose to do here is show you what it is. And I wouldn't worry about this uncertainty. There are things you can do to lower these numbers, these percentage numbers and the values here. The ones here are not really out of line. They're in a pretty good range. There can be uncertainty percentages and values that are much larger than these. For example, if your pressure shift is less than 17, we have a pressure shift here of from -32 to -15. That's a pressure shift of 17. If the pressure shift is less than that, these uncertainty values will go up. And there are other things you can do to make the final result more accurate. And that would mean that these uncertainty percentages would come down. Finally, what we find here is the percent of the whole house leakage passing through the zone is 42%. That is this value right here, 1,000, and that is 42% of the initial whole house CFM 50. So that's where that comes from. I want to give you a little more information about what each of these values mean in the results. Notice the title is the results for initial zone configuration. The only reason we modified the zone was so that we can find these results for the initial configuration where we started. First of all, the house to zone is 1400 or 140 square inches. The zone to the outdoors is 2000 CFM50 flow rate and 210 square inches. And the through zone is 1000 CFM50. Now these are represented on this illustration. You can see the zone to the house or house to zone either way. We have 1400 CFM50 flow rate and approximately 140 square inches. For the outdoors to the zone or zone to the outdoors, we have 2000 CFM50 flow rate and approximately 210 square inches. Notice that the square inches is pretty close to dividing the flow rate by 10. Not exactly, but almost always quite close. And the total path is 1000 CFM50 flow rate. We don't divide this by 10 or try to determine the square inches because this is for both of these it's passing through both of the pressure boundaries, the roof, gable end, and the attic ceiling. And notice for the initial configuration, the whole house CFM50 is 2400. So if we look at these in order, first of all, the house to the zone, zone to outdoors, and the through zone, a few details about each one. This is the zone to the house or house to zone, same thing, of 1400. This is the leakage through the pressure boundary, that is the attic floor, as if the other pressure boundary, the roof and gable ends, were totally removed. This, of course, is not going to happen, but this gives us the capability of being able to divide the number by 10 and get approximately the square inches of leakage. And that's quite powerful. Of course, we can do this pre and post weatherization and find out what the pre-weatherization square inches is, and then find out what the post-weatherization square inches is. And keep in mind that every square inch that the workers in the attic seal will reduce the flow rate, the CFM50 flow rate, through this boundary, through the attic floor, by about 10 CFM. Then for the zone to the outdoor, or outdoor to zone value, this is the flow through the roof as if the ceiling were totally removed. Of course, this is not going to happen, but again, it gives us the capability of finding the approximate square inches of leakage. We have 210, and this gives us a very good idea, perhaps the best idea possible, of what the effective attic venting is. We don't have to go measure it with a tape measure, but this would include the vents that are already in place, and it would also include any leakage in the soffits and things where there are not intentional vents. And then finally, the flow through the zone, the through zone flow or the total path of 1000 represents the combined leakage of both pressure boundaries, the ceiling gable ends and the roof acting together, or in other words in series. Both of these impose resistance to airflow. Therefore, the total path CFM50 is always less than either of the other two numbers. And as we have already gone over, the total path number of 1000 gives us the idea of the leakage through the top of the house. And there's an example here, 42%, which is portrayed in the red tool results. This means that the leakage through other parts of the house would be 2400, the whole house leakage, less the leakage through the top of the house gives us 1400 CFM50, which is the leakage through the remainder of the house. Now again, here are the values in the red tool. I just went over and explained these. And these are the values, again, maybe a little easier to understand them here because they are in diagram form. Now again, here we have the house to the zone is 1400 CFM50 flow. The zone to the outdoors, the other pressure boundary, is 2000 CFM50 flow. And the through zone or total path is 1000. Again, this is always going to be less than either of the other two because it's taking into account the resistance of airflow through both of the pressure boundaries, not just one. I'm going to show you now the advanced input section of the red tool. The tool is still filled in with the inputs and the results from the garage as the zone. I will click on this box next to Use Advanced Inputs. You can see that this section of the tool opens up. I can click on it again and it closes up. When it opens up, it will use the values that are in that section of the tool to come up with the final results. If I unclick it, now those values will not be used in the final results, although they are still in place. So I'm going to click on it. House temperature, this is the inside of the house. The outside temperature and the zone temperature. All of these will have an impact on the blower door readings and the pressures and the flows because the temperature of the air has an impact on the density of the air. If the zone is well vented to the outdoors, this might very well be the case if it's an attic with ventilation. And remember, if you have questions about anything here, you just click or touch on the label and it gives you an explanation of what that input or result has to do with. If you think the zone is well vented like an attic, you go ahead and check that, and some things are done under the hood to make things more accurate. The building pressure exponent, this is a typical exponent right here, 0.65. That's the default value. If I were you, I would leave it there unless you have done a multi-point blower door test and you have an individualized building pressure exponent for the particular house. But the only way to get that is by doing a multi-point test. If it's a windy day, what you probably should go ahead and do is enter 3 baseline pressures at 5-second intervals. You can see what I have added here. A -3, a 0, and a -5. Now, if you do get baseline pressures like that at your blower door, this is for the whole house, that's a good indication that it's windy. Now, this will not have an impact on your actual results, but it will have an impact on the uncertainty. I'm going to scroll down here And if you look at the uncertainty now, you notice these values are higher than they were. I will unclick advanced inputs in a moment and I'll scroll back down here. These values remain the same, but the uncertainty values such as this one and this one have gone up because it's windy. And if it's windy, it will have an impact on our results. They are less accurate or more uncertain. Now I'm going to unclick this. Those values are still there, but they're not now being used for the calculations. Notice how the uncertainty values have gone down. So if you use advanced inputs, I suggest you do so if it's really windy or if you've got temperature, low temperatures for most of us, this would be. Or you might use it if you're doing an attic and it's very well vented to the outdoors. Or if you have an actual building pressure exponent from doing a multi-point blower door test, I suggest you use advanced inputs. If not, just leave it alone. Life will be a bit simpler without it.